This lesson will help you understand the phrase as a function of. To understand this phrase, I'd like you to consider the following example. Here's a rectangular garden. Here it is divided into two parts. Notice the problem did not say the parts needed to be equal parts, so I won't assume that. They also don't tell us how this rectangular garden is divided, so I won't worry about where I put this divider. Now let's pose the question. Find the total amount of fence that we would need to build this garden. Well, it doesn't appear that there is enough information in this problem as stated. And to show you that there doesn't appear to be enough information, let's consider the following example. What if I were to make this garden with a length of 12 meters? I'm not saying that that's the answer to this problem, I just want to ponder this question. Well, if the area of the garden has to be 216 square meters, then I can figure out what the width has to be. In other words, 12 times something has to equal 216. Well, a little math will show that 12 times 18 is 216, which leads me to conclude that the width would have to be 18 meters. Again, this isn't the only way to build this garden, but it is one way to build it, to have that area. Well, now let's consider the amount of fence by putting our divider in. The total fence used will be adding all 5 sides, including the divider. And in this particular example, all 5 sides added together works out to a fence usage of 72 meters. I'm not suggesting this is the answer to the problem, I'm just pointing out that this is one way that this garden could be built. But it's not the only way. What if we made the garden wider? Suppose that we had a length of 9 meters this time. Well, again, the area has to be 216 square meters, so I could figure out what the width has to be by figuring 9 times something equals 216. Well, if you put a little thought into it, you'll eventually discover that 9 times 24 is 216, which leads me to conclude that with a width of 24 meters and a length of 9 meters, I would have an area of 216 square meters, and that this would be another way to build this garden. Now let's consider the amount of fence used for this example. Putting in the divider, and again adding up all 5 fences, including the divider, we could figure out that this particular way of building the garden would require 75 meters of fence. Well, that raises the issue that this question here, finding the total fence used, doesn't have a single answer because there's more than one way to build a garden whose area is 216 square meters. So let's consider a different question. Notice the phrase in green, that's our phrase of the day, as a function of. What would it mean to find the total fence as a function of the length of the divider? Let me take you through a thought process that will help you understand this question. In the previous examples, we used 12 meters for the length, and we found the total amount of fence. And then we used 9 meters as the length and found the total amount of fence used there as well. But when they say to find the total fence as a function of the length of the divider, what they're asking us to do is to consider a variable length of that divider, call it d, and see if we can still use algebra to find the total amount of fence used. Well, if we want to find the total amount of fence used, we're going to need a different variable for width. Now, you'll remember in the 2 previous examples, d and w were specific numbers. But let's consider a more general case where we're trying to find the total amount of fence using these variables instead of numbers. Well, the amount of fence used would still be all 5 fences added together. And using some 8th grade algebra, we now have the amount of fence used as a function of, or using an equation with these variables. But this phrase right here has a specific meaning to it. It is implied that when you're asked to find something as a function of a quantity, that no other variables are allowed other than the one specified, in this case d. And so my goal is to convert this equation into an equation with a single variable. So, because I want it as a function of d, the divider length, it's essentially implied in this question that I can't have a w in my function. So I've left the blank parentheses where the w was. Now I'm going to show you a clever way to fill that in without using w. The first thing we have to do is think about how d and w are related to one another. We saw an example where d is 9 and d is 12, and w had different values in each instance, and it turns out that the divider length d could be essentially anything we wanted it to be. I could have d be 100. I could work this garden so that w is 100. But I couldn't have d and w be 100 at the same time, because then I would exceed my area of 216 square meters. So to find an equation that must be true using d and w, I have to consider the fact that while d and w can be anything, I have to pick values of d and w so that d times w is 216. And this equation that must be true is going to help me fill in the blank parentheses at the bottom. Cool trick. I can divide both sides of this equation by d, and that gives me w equals 216 over d, which means I could replace w in my fence equation with 216 over d. And after a little 8th grade algebra, I have the answer to this problem. Well, now that we have the answer, let's go a little bit beyond the answer and figure out what it actually means. First of all, a few comments. This equation that must be true, we call that the constraint equation. Furthermore, this answer to the question you may occasionally see written this way. This thing in the box does not mean f times d, it's pronounced f of d, and it simply means that the value of f depends on the value of d. Well, of course it does. We noticed earlier that when d was 12, f was 75, and when d was 9, f was 72. So of course f depends on d, and these parentheses around the d, again, are not multiplication. They're just a notation that shows that the value of f depends on the value of d, which makes sense that it would, based on our examples. Let's go a little bit further into what it is that we just found. Here's the answer to this problem, but what does it actually mean? Well, remember the example where d was 12? What if I were to plug 12 into my newly created function? If I found f of 12, some easy algebra shows that it's 72. And that's just consistent with what we saw earlier. Remember the example when d was 9? It should come as no surprise that if I plug 9 into my formula, if I find f of 9 and work out the math, I'll find out that it requires 75 meters of fence, which is consistent with what I found earlier. So you see, when we find this as our final answer to the problem, what we've really found is a formula that tells us the amount of fence we'll need for any possible choice of divider length. Not just the two examples we did earlier, but any other choice we could make for D as well. That concludes the lesson.